Hello and welcome to section 3.1, Extrema on an interval. And in this section we are basically going to talk about the extremes of a graph. And the plural of extremes of extreme is extrema. And so basically what we're talking about is we're talking about either maximums or minimums. And in this first example here, or in this first illustration, they're talking about absolute maximums and minimums, and they can happen at different spots on the graph, and so you need to kind of keep track of this. If you see the word absolute for a maximum or minimum, then you have to include the endpoints. So these endpoints could be a maximum or a minimum, and in this case, if you look at this graph, this is the minimum, and the absolute maximum is over here where the graph ends in the interval, in the closed interval. Alright, so it'll change a little bit when we don't have closed intervals, but on the closed intervals we can have absolute maximums and minimums, so make sure you get these down. And then, well, here's our definition of a maximum or minimum, and basically what it comes out to is that if we have a value in a function and it is the biggest value in the function, then it is a maximum. If it is the smallest value in the function, then we have a minimum. And so this kind of goes along with the same thing as the last slide, but the definition is the new part, and they're just saying if you plug a value into the function and it becomes larger than any other number in the function, it's a maximum, and if it's the smallest in the function, then it is a minimum. And so that will be our test along the way. So we need to make sure that for our extreme value theorem basically says that if a function is continuous in the interval, and then it will have both a maximum and a minimum in it. So as long as the function doesn't go on forever, at some point there will be, if it is a closed graph, and we have something that starts and stops, then there will be a minimum and a maximum. Now, my illustration here isn't the best illustration in the world because my maximum and my minimum are both my beginning, my A and my B values on my closed interval. But that doesn't necessarily mean that's the case every time. I could have had a graph that did something like this, possibly. Maybe that stop there, and we would have, okay, this is my minimum down here, which is one of my endpoints, but then I have a maximum over here, and that would be, so it doesn't have to be the endpoints, but when they're talking about absolute maximum and minimums, or they give you a closed interval, you have to make sure you check the endpoints too. Alright, so then relative extrema, or when the function is, this is what we're going to spend more of our time on, is relative extrema, and basically what relative extrema are the maximums and minimums in a function that is continuous. And so you can have the difference is you have an open interval for relative extrema instead of the closed interval for absolute. And again, relative extrema will be, you'll have an f of c value that is the biggest in the function when it's a maximum, and you'll have a f of c value that is the smallest, so when it is a relative minimum. But this doesn't have to be a closed interval, and what we'll do is we'll do some calculus to figure out exactly how we find these relative maximums and minimums. And so the difference is relative we are on an open interval, and absolute we're on a closed interval. So then, what ends up happening here is, well, let's go back here real quick and look. When you're looking at these absolute maximums and minimums on this graph right here, you may notice something about them. There's like a peak and a valley when we're dealing with them, but you'll notice that what's happening with the slope of the line at that point. What's happening with my slope? Well, you'll notice that the slope there, when we get a maximum or a minimum, is a slope of 0. And so these are what we call critical numbers, when we can find out the slope being equal to 0. And so that's what the next slide is all about, is that if we were to take the derivative of a function, we would find that if we can set the derivative equal to 0, we will find a critical number. And that critical number will be the possibility of where a maximum or a minimum would appear. And so the two things that we have to do is we have to find out when the derivative is equal to 0, or when the derivative is not differentiable. So I got two drawings here. The first one is when f prime of C does not exist. So at some value there's a point, but it doesn't exist, so we got to check and make sure that there isn't a maximum or a minimum there. And also we can set it equal to 0, and we will find out that there's a horizontal tangent there, and those are both ways to find critical numbers. So if f has a relative minimum or a relative maximum at C, then C is a critical number of f. And so this is basically just saying that if we can find a horizontal tangent or a place where the derivative does not exist, then there's the possibility of a maximum or a minimum. So then here's our guidelines for finding extrema on a closed interval. And basically here's what we're going to do is we will, just depending on whether the function is continuous or on a closed interval. So if the function is continuous in a closed interval, then we're going to follow these steps. We're going to find the critical numbers of f in a and b. So finding critical numbers will be dealing with the derivative. So f prime of x equals 0. So we'll find the x values where our derivative is equal to 0. We'll evaluate each critical number, so we'll plug in those numbers back into the original function to figure out whether they're maximums or minimums. We will also, since we're on a closed interval, that's this part up here, closed interval, we would check the endpoints a and b also. If it's just an open interval, we don't have to check the endpoints. And so then these guys will be the maximums and minimums where the derivative is equal to 0. But in this case, if it's closed interval, then we have to check the endpoints too. And then, of course, the smallest value will be the minimum, and the greatest value will be the maximum. So this concludes our 3.1 notes. If you have any questions, please come to class prepared to ask them, and we will talk more about them, all about this stuff in class.